Hi, everyone. Welcome to another edition of the community call. This time in today's community call, we have Lucian here from Bodyguard AI, who is a senior data engineer there. And today, we'll be going over building an open source data platform in 2023. And I'm so excited about this community call because it's very different than everything else we've done in the past, right? Usually it's always how to use Airbyte with, X company who's presenting, right? How to use Airbyte with this. But in general, now this community call is pure value, everything about open source and data engineering. So I'm really excited about this. So Lucian, I want to welcome you to this call. What time is it for you right now, Lucian?
Actually, it's 7 p.m. right now in France.
Are you in the office
So
too?
yeah, I'm still at the office to get like
Dedicated.
better stuff. Yeah. But yeah, I
No.
feel excited to talk about the work we've done here at Bodyguard. So we built an entire data platform, which still use Airbyte, of course, because it is not like random that we are here, but I'm
Yeah.
excited to talk about it.
No, same here. And I just want to introduce you real quick. So for people who don't know who Lucian is, so Lucian, and you are a senior data engineer at Bodyguard AI, right? And you got your degree in computer science. You have a background in computer science, and you've been in tech in the data engineering space since 2015. So you have quite a bit of experience. So that's impressive. And then seeing where you are now and what you do at Bodyguard AI is exciting. And so again, welcome to the call. And you know what, Lucian, I'll let you go ahead and take it over from here.
So, hi everyone. Thank you for being here for my presentation around building an open source data platform in 2023. This kind of a return of experience about our work here at Bodyguard, and we will deep dive into our platform, our technologies, and also our principles uh, with we build the data platform. So just a few words on myself. I'm Lucien. Like we said earlier, I define myself as a data platform builder. So it's a bit more like a just data engineer because I also own all the infrastructure part. I'm also responsible of everything related to production, operation, and so on. So here my work is really to um, build the platform and maintain this platform. And the thing I like in the data world is to apply all the software engineering best practice into the analytics and BI world, which is not always the case. And I suffered from this for in the past, in the last some of last experiences. And here at Bodyguard, we have really the opportunity to put the best practices like testing, like coding, like Git, everything into the analytics world. So what is Bodyguard? Bodyguard, so that's my company, is an intelligent and automatic technology that protects individual and businesses against online toxicity. So here our work and our mission is to moderate and stop all the racist, sexist content, all the hateful content we can face on the internet for the social networks or for an API access. So we are mainly working with within the sports industry, within the gaming industry, and within the media and brand industry. Okay, so let's start around our work for the last years here in Bodyguard. Let's talk about our main principles that we put to build our data platform. So first one, which is really important, is make everything as code. So we don't want here to click anywhere on a UI, on GCP, on Airbyte and everything. And we want to make everything as code to be able to rebuild everything from scratch. If we have like, for example, a disaster. So if we lose like an entire GCP region, we can rebuild everything. Or also if we expand in a new region, like for example, we are now live in the US, and it's really easy to build the same infrastructure in the new region because everything stick to the code. Also, it's a great way to have like a dedicated infrastructure for every developer in the team. So I have my own infrastructure and I can make some tests and code my features without any side effects to my coworkers. First one, maybe the most important. Second one is we want to ingest as many sources as possible, which can be databases, which can be SAS, which can be many various sources, and we want to ingest them in a very generic way. So for me, I treat data as a really generic flow. So I don't care what's inside the data. I just want to be able to ingest them in a very generic way. Also, we care about standardization. Here at Bodyguard, I have the opportunity to benefit from a Kubernetes cluster from our platform team. So we want to use as much as possible open source software that are Kubernetes deployable through a YAML file, which is now a very standard way to build and to deploy resources. Fourth principle, we want to rely on open source storage format on a standard cloud bucket. So we don't want to put all our data in a data warehouse like a BigQuery or Snowflake because there is kind of a lock-in. So rather than doing this, we want to store every file in a Parquet format, which is really the standard in a storage bucket. Has some advantages because if we want one day to change our data warehouse solution, it is possible thanks to this principle. And the last one is more into the user-facing side, the consumption side, is that we don't want here that every business team have a data analyst that make like a SQL request in, I would say, a messy way. So it's really important that our team owned and define which we call a company level KPI library. So we provide to the users a KPI. Like for example, if I want to provide like the monthly recurring revenue, we will define, model, and publish this KPI, which can be consumable by business user at Bodyguard. But we don't want them to compute and define their own KPI. So that is the main principles which are trying to stick. Now let's deep dive into really the technologies and the bricks behind these visions. Let's start with obviously Airbyte. It's not a surprise. So we rely on Airbyte to ingest all the data sources we have. So this is really the entry points of our data platform for the Postgres database or for the ACS. The two main advantages of using Airbyte are that I don't have to code all the API boilerplate scripts because with Airbyte, it manages all this API part, and I can focus on more complex things or more added value things. And also, Airbyte has kind of a standardization mechanism. So every data that are coming from Airbyte has kind of the same structure and same aspects. And for us, it's really easier to ingest them in a generic way because we have this layer of standardization. So next is around the storage. So we rely on a Google Cloud Storage and Parquet format, like I said earlier. But the interesting things on the data platform is our lakehouse approach with the technology provided by Google, which is named Big Lake. Big Lake is like a link between the storage on Google Cloud Storage and the compute on BigQuery. So with Big Lake, I'm able to perform like SQL requests with data that stays on Google Cloud Storage, which is really interesting because BigQuery is one compute engine, but I can have like other compute engine, like for example, a search engine, but the data stays, the source of truth stays at the same place, and we don't move those data between Google Cloud Storage and BigQuery. So this is really, for me, the key of our approach is provided by this lakehouse pattern thanks to Big Lake. Then we have the data that are coming from Airbyte like every hour or every day. And we ingest this data thanks to dbt and their incremental models that allows us to provide two layers. So one layer, which is named Silver, that is the current state of the database. Like for every row in this data, we are merging this data. So we are getting only the last event. Like, for example, if a user changes his email address several times, in the silver layer, we will only keep the latest address email with the max timestamp. So this is for the silver. And then we have the bronze layer, which contains all the updates, all the historic the user has. So if I get back to my email example, in the bronze layer, we will have all the emails for a given users. So we have kind of these two layers, one which is based on a merged statement on SQL, and the other one is more like an append any new data. And these things are really like making easier by DBT incremental models, which reduce all the boilerplate and allows us to make this ingestion, make this merge operation really easy. So now we have all the data pipeline like ingestion, transformation, and storage, and we want to be able to orchestrate these data pipeline for every connection. So we are using Prefect. I don't know if I guess some of them knows about Airflow, which is a famous orchestrator in the data world. Prefect is, I would say, a more advanced and a simplified Airflow.
I was just about to ask why did you choose Prefect over Airflow? That's very interesting.
Yeah. So with Prefect, you do not have any boilerplate code. Any Python function can become a flow, just adding a decorator like at flow, and any single function can in plain Python can become a perfect flow. And also from an infrastructure point of view, Prefect is only composed by a server and an agent that consumes the queue in the server, and it's really easier to operate rather than the Airflow that use many breaks and it's hard to maintain an Airflow instance. So Prefect is way more modern, I would say. So to resume, in Prefect, we are like saying to Prefect, like every hours, every day, trigger this pipeline through Airbyte API, DBT API, and the convenient thing is also that the Prefect team provide package like Prefect DBT and Prefect Airbyte to easily manipulate and interact with these APIs. So very convenient. So that's it for the ingestion part. Now we will talk about really how consume these layers, this raw data, and we want to now add business value, and we want to add value, provide value to our final users. So the really key of our data platform is our modeling layer based on a technology that is named Cube. So just for the story, Cube can be seen as the modeling part of Looker, but the difference is that it's open source and it does not provide any visualization capability. So Cube is really like the entry point of all the consumption in our platform, and we define metrics, define measure, we define dimensions to be able to provide our KPIs to our users. The really nice thing with Cube, it is also that obviously the modeling part, but it's also as a security mechanism that we can control and ensure that users have the correct sets of permission to use this data. It also provides cache mechanism. Like for example, if you make the same query multiple times, it will be cached at a cube level, and it will reduce the cost of on BigQuery. And also, last but not least, every KPI on Cube is automatically amplified, I would say. So it's really easy to consume this KPI through a regular code in a regular web application. Okay. So now the question is, what are the tools to consume the Cube metrics? So first one is Superset. Superset is also an open source. Every technologies here, except from BigQuery, are open source and deployed on our Kubernetes cluster. So Superset is really like the BI tool to have your charts, to have your dashboards. But the interesting thing is we don't have business complexity at Superset level. We use Superset only to consume and to visualize metrics that are defined by Cube. And the interesting thing also is that our charts are defined by code. So we do a pull request with all the JSON JSON code that define a chart thanks to the superset export function. And then our users can create dashboard and add charts, compose them, and everything. And the next one is, like I said, it's automatically API-fied, so we can use Cube KPIs directly into our front-end code to display statistics and so on. So that's it. I would say it, but it's already kind of complex for all the technology we used. And I try to summarize them in a more like a high-level perspective. So if we start on the left of the screen, we have all our Postgres database. We have all our SaaS sources, which can be HubSpot, our CRM, which can be Notion, Intercom, and every sources are ingested within Airbyte and come in.
Hey, Lucien, sorry to interrupt you. Someone just had a quick question really quick before you go through this.
Sorry, I don't want questions, so don't hesitate to.
Someone asked, I believe the idea here is building a data platform with fewer node pay tools, correct? Could you please explain how you do that in a data storage step? Again, if you see if you can clarify that.
Okay, so we are talking about NLP, that's it?
Yep.
No pay tool, the data storage. So we are, to be clear, we are paying for the storage on GCP for sure. So we are using as much as possible. So we don't pay for license, but for sure we pay for storage and compute. We pay GCP for the Kubernetes cluster. We pay GCP for BigQuery. We pay GCP for the cloud storage, but we don't pay Airbyte for using the technology. We don't pay Superset. We don't pay.
Wow, a lot of questions are coming in now.
Clear?
Yes, that was clear. So there's quite a few questions. If you're okay with answering these questions first before continuing.
Yeah, sure. No worries.
Okay, excellent. And so someone else asked, what is build KPI technology, and what models do you use?
Yeah, to be clear, we used Cube in order to define these KPIs. Maybe I can show you directly on my screen. So Cube is really like the data modeling layer, and in Cube you can define in JavaScript or in YAML, but we don't care. Some things we can call measures that are basically counts, and dimensions that are basically column. So here in this example, we have a cube which is active user, which is based on the raw data. And then on this cube, we can calculate and define a business metrics, and we can define them as much as we want. And so all the business value is stored at this level. I don't know if it's clear.
It's clear.
Is there also any question or?
Yeah. And then another question. Oh wait, I'm not sure if I was reading the questions. If you answered, what models did you use? What do you use? Did you answer that question?
So we use Cube in order to model, but beyond the word model, it's more like defining business metrics.
Okay, excellent. And there are more questions coming in. I'll let you continue with the presentation because there's more questions coming in, and I want to make sure you finish your presentation too. But yeah, well, please keep asking questions. But we also want to make sure we give Lucien time to finish this presentation for those who want to see the whole thing as well. So thank you, everyone.
Sure, I will take some time at the end for every question. So let's start again. So like I said, everything is triggered by Prefect. We Airbyte send and store packet files on Big Lake. We are using dbt to merge the newly arrived data and set up our two different layers. And then based on the raw data, we used Cube to define all the KPIs. So to summarize, Cube as an input, we have the raw data, and as an output, we have the KPIs that are business related. So this is really the way to pass from something which is really like the mirror of the data sources to something that has a business meaning. And then we have our three different tools to consume these KPIs. So Superset for the BI, directly in the web application, or even with a Jupyter notebook for our sciences team, which can consume also the same KPI. So the benefit of this approach is if one KPI change, we can update the monetization behind this KPI, and it will be automatically synced with all our consumers. And it's really something different that having a BI tool like Superset or Tableau that is directly plugged to the raw data, and with every people that are recomputing the same kind of stuff for different team and different level. So in that case, if you have to change one KPI, you have to go in many dashboards, change the rules. So it's really complicated. With this approach, if we change the rule, it's automatically updated in those three tools. Okay, so now the last part of this presentation is a bit of a deep dive into Airbyte and our data collection process. Because like I said earlier, we don't want to define all the Airbyte configuration through the UI. So the good thing is that Airbyte provides us a really nice tool, which is named Octavia. Octavia is a tool to manage Airbyte configuration through YAML. So we are able to define sources, destination, and connection like you would do in the Airbyte UI, but we can do it through a YAML file. Then we are able to apply these configurations through Kubernetes job and then store the YAML file and also store the states of the Airbyte resource. So I will try to make like a quick demo around Octavia. So I'm crossing my fingers that it will work pretty well. So let's go into my code. So here is the typical Octavia folder. So I can have sources, many destinations, and many connections. For the demo, I use some testing sources and testing destinations. Hopefully, Airbyte provide one which is named Poke API, which is ready for testing purpose. So here is the definition of the sources. The sources has a name, a type, an ID, and a configuration. The configuration is really light for this API because it's really like a testing API. But for example, for Postgres, you can define credentials, you can define like a replication option. Also. So this sources only take one argument, one configuration, which is the Pokemon name. So okay, let's apply. Also, I would like to show you that I have a local empty Airbyte instance. So if we look at sources, we can see that we have no active sources. So now we are trying to apply these sources. So we are using based on Octavia, which is provided by Airbyte. And then I can apply my sources, which is based on the configuration file I showed earlier. So let's start. Okay. So Octavia says that Poke does not exist and is it successfully created. So let's check on Airbyte, maybe a bit of delay. Yeah. So now we have these sources. So we didn't create it through this button. We are really like using Airbyte API, programmatic access for defining it. We can do the same with the destination, which is named end-to-end testing, based also on a configuration file, which is here, which is also really simple because it's really like testing destinations. Okay, successfully created. Nice. We can check also in the Airbyte UI with a bit of delay. So yeah, now we can see this destination. And now we want to create a connection that links our sources with the destination. So we have the third YAML file, which is a bit more complicated because it defines a connection which is based on a source, on a destination. And we have here all the schema that is generated by Airbyte. I didn't write it this myself. That specify all the columns we will have. So let's do the same for these connections. Okay, it seems to work. Also, we can see here that Octavia created a state file, which enable Octavia to not create the same resource twice. Like for example, if I tap the command again, Octavia says that the connection already exists. And if I go for yes, normally it will create it once. So it won't create a second connection because it knows that it already exists. So I can start and run the synchronization. It will take like around 1 minute normally.
This always happens to you when I give demos live. We're syncing takes 1 minute, and you just have to think of a way to
Yeah,
keep talking.
it was really fast because it's really like, and we can see here because the output is only in the log that we have one Pokemon which is returned by the API. If I go for something like JSON parser and removed the beginning like this, we will see here the response of the Poke API, which has been collected by Airbyte and sent to a destination, which is a really simple destination, which is only like a login destination, but it could be any data warehouse like BigQuery or any bucket like a GCP bucket or AWS bucket. And we see that we get the same Pokemon with some properties. So that's it for the presentation. I would be more than happy to answer any question. I hope it was clear enough and it was not that boring. I hope you enjoy it.
It was very clear. To be honest, it was one of the more entertaining calls I've heard in a while. So I appreciate you putting that much effort into it. So we have quite a few questions in here, and it looks like some folks from your company are answering, which helps a lot. So someone did ask a question, which I asked you earlier, which is how many people are on your team, and roughly how much time has gone into this particular solution that your team has created?
Yeah. So here at Bodyguard, we are a tiny company. So the data team is quite small. So I am the only one data engineer. I started working there like a bit more than 1 year ago. So I built everything and I'm working with Alex, which is the analytics engineer. And here the analytics engineer is really the one that are building all the modeling through Cube. So Alex is like talking with the business and then taking all the business inputs to modelize them into Cube, and then he helps in train the business. And also we have a third people, which is a data scientist, who is a data scientist, and he's working to train machine learning models, and he uses the data that come from the data platform.
Okay, amazing. Thank you. And someone also asked, are you using dbt for merge and append?
Yeah, we are to be clear, we are using dbt only for this merge append operation. We are not using dbt to define metrics, to compute business things. This is really like something that is only in Cube.
Okay. Excellent. And I know someone's answered these questions, but for people who also watch this on YouTube who don't see the chat as well. And so someone also asked, since BigQuery changed the pricing model, do you plan to change something in your architecture? Are you impacted by this pricing model change? That's a good question.
Yeah, it's really a good question. To be honest, BigQuery is the most costing part of our infrastructure. And maybe one solution to give like really open source focus would be to replace BigQuery by something more like a ClickHouse, which is an open source data warehouse, but it's really like technical. It doesn't bring a lot of user values, so it takes a lot of time. And also, if you understand well, we rely a lot on BigLake, which is the proprietary GCP technology, which can link storage and compute. And I'm not sure that we could make this lakehouse pattern using something like ClickHouse and something like I don't know, Minayo, which is open source buckets.
Okay.
But it would be to be 100% open source. We would go for something like Minayo for the storage and something like ClickHouse or maybe DuckDB for the compute part.
DuckDB. Nice. And someone asked this question. Now I was curious too. I was excited to see you use the Octavia CLI, which is cool. Seeing someone do a live demo, by the way. Good job. So why are you using the Octavia CLI and not using the Airbyte UI? Someone answered this question in chat, but yeah, for our YouTube viewers.
This is really linked to one of our principles. This is making everything as code. So if tomorrow I have to deploy a new Airbyte instance, it's only like making a Octavia apply in a new environment as a target. And I don't have to go to the UI making the same click that I did before. And also it's really convenient because we can define something in a development environment that we are pretty sure if it will work the same in production. Because if I make some stuff manually on the dev environment, it's really hard to make exactly the same clicks, in the production, and you will have trouble. So this is really like we trust the code, we trust pull requests, we trust reviews, And then we can have all the software engineering process applied to the configuration.
That is so interesting. That makes total sense though. And one two more questions from here, and I'm going to combine one of them. How do you manage the observability of the platform at the data level? And for alerting and
Yeah.
monitoring, are you using any tool, right? Like for example, let's say a job failed.
As I said before, I am very lucky here because I can benefit from a very good and very well monitored Kubernetes cluster. So the
Mm,
platform team did all the jobs around this cluster. So all the metrics are exported in a Prometheus instance. Everything is monitored through Grafana. So if one of my pod, like for example, each traffic pipeline is a Kubernetes pod that is populated, if this pod fails, it will be automatically pushed into Prometheus, and it will be automatically pushed into a channel stack. So I don't have to set myself all the notification parts. To be honest, I don't use the notification mechanism from Airbyte, from Prefect, and anything because it's more at the Kubernetes level, and I use this thing that has been built, and it allows us to gain some time at this
mm.
observability level.
Excellent. And last question. Someone asked, is security handled by Cube as well?
Yeah. So, like I said before, you can add in the kube request something which is called a security context. So, for example, when you are using a superset, it will be bind to your Google identity through SSO. So, when you are making the display button on superset, it will transfer your SSO identity into Cube that can check that you have enough permission to access the data, or it can even show you different data based on your identity. Like for example, we have different sales for different industries. Like if sales want to see his performance, it's only one dashboard, one KPI, but it's based on on its identity.
Excellent. Thank you. That looks like that's the last of the questions. Lucien, seriously, I want to thank you for joining this community call. Any last words you want to share? Anything you want to share about Bodyguard AI, yourself? Where can people find you if they have additional questions?
I'm thinking about no. I enjoy, to be honest, I enjoyed making this presentation. I'm really like passionate about what I build. So for me, it's really a pleasure to talk about it. And if you want to reach me on LinkedIn or on Twitter for more information or for anything that you want, it would be a pleasure.
Excellent. Thank you, everyone else, for joining. This will be uploaded onto YouTube in about 2 days. So thank you, everyone. As well, thank you, Lucien. Talk to you again soon.
Thank you.
Bye.